Good day, folks. It's Tony Fortunato from the technology firm. I'm going to walk you through another troubleshooting exercise that I got a lot of feedback on. People really enjoyed this, so I figure I'll just do another one with you. And again, if you like more, I'll keep doing more. So this is the infamous troubleshooting example where I'm using this TAP from Network Critical SmartNA XL. And what I've done is, here's a client. I put it right into the TAP and tap back out to the switch out to the firewall, and now the outside of the firewall is being monitored by the test tool, and then out to the internet. So my laptop has two Ethernet adapters, the built-in one called Killer, and then my docking station. And I've already tested this. The docking station doesn't add a whole lot of latency, not enough to affect this scenario at all, so I'm good to go. So it's a pretty, I'm going to say a standard layout. I don't want to use span ports for a whole bunch of other reasons, so in this case I decided to use a TAP, and we're going to go through this example. So now we have two trace files, one from this side, the client side, and one from this side, the firewall side. Again, the outside of the firewall adapter. The reason why people are enjoying this is because the outside of the firewall obviously is going to give us different packets than the inside of the firewall. So for example, the client, here's the client, there's a destination, just Google DNS, and on the outside of the firewall you see the outside IP of the firewall, not the client anymore. You see that changed? Okay, so people are always asking, how do I track a packet through a firewall, or whatever, it doesn't matter. So how do you track that? So I'm going to go through that again. So the first thing I'm going to do is I have my two trace files. I've pre-filtered this. And that's a trick you can use when you go through like a firewall, is filter on the protocol, kind of step one. So I've done a filter on DNS, and I've saved the trace file, and I've called it DNS fail firewall, so I know it's on the firewall side with pings. And then this is DNS fail client with pings. That way at a glance I know this is the DNS trace and this is the client side. Fail means obviously it didn't work. There's a part in here where it breaks, and obviously there's some pings in here as well. So that's step one, right? So make sure you filter this stuff out ahead of time as much as you possibly can, just to make things easier on your brain, and then give it a appropriate name so you know how to track it. So if I start with the client side, because again, troubleshooting, I always start from the client side first because they're the ones complaining, they're the ones who can tell me when it happened, the time, and all that kind of stuff. So that's what I'm going to work with. And step number, I'm going to say 2, is to set up your tool properly. So I don't want colors. It actually gives me a headache, to be honest with you. So I'm turning it off because I don't have a need for it right now. Second thing I'm going to do is turn off the packet details and the packet bytes on both of these. So view, packet details, view, packet bytes, view, packet details, view, packet bytes. For the people who know a little bit about Wireshark and my other videos, you can set up a profile with all this ahead of time. I'm doing this longhand just to show people, kind of worst case scenario, starting from scratch. And now we have to find out where this breaks. Now this is kind of easy with DNS in a way, because you'll see a command and response, a query response, and if you look you'll see a pattern here, right? You'll see client server, server client, all the way down the line. So if I simply just page down, I'm just going to page down, you'll see the pattern maintains itself, and page down, and then all of a sudden here at the bottom the pattern breaks. See that? So I can just scroll up a bit. There you go. And instead of this bing, 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 it's this something happened here, right? So I can see the client sends out a request, and I've turned on view, packet display format, second since previously displayed packet, and that's telling me the delta time. So there's a DNS request, didn't resolve. A second later, I retry. A second later, I retry. 2 seconds later, I retry. 4 seconds later, I retry, and then I get a response. All right, that's the pattern I see here. So I can do the same thing here. I can just simply go to this trace file and hit page down until this pattern breaks. I could also search for some specific stuff in both traces, and that way it comes out a little easier in my brain. So there's a few ways of addressing this side of the trace when I get to it. So let me just find this part where it breaks. And it looks like it's fine. See that? So now this is a very common scenario where, hey, look, the firewall didn't see those patterns, so it's not the firewall problem. It's like, wait a minute, that's the outside of the firewall. So I don't know if it got to the firewall. And did these two get through and those did not? We have to find out now. So what's the best way to do this? Well, now we're going to turn back our packet details on, the packet pane. We're going to find this query, right, this last query. And I'm going to use something relatively unique to DNS, and that's the transaction ID. There it is. I'm going to right click, I'm going to copy, and what I'm going to do is copy this as a filter, okay, because I'm going to just paste it here and paste it here. So now I have the same trace on both sides, and as you can see, it's look at that. So this all went to the firewall, but only these two came out. So the question is, this first one, this query, is it this one, this one, this one, this one? Like, which one is it? Because they all have the same transaction ID as evidenced by our display filter. So what do? So now we're going to use a different part of the packet to try to figure out which is the case. So I'm going to collapse my DNS. I'm going to open up my IP header. I'm going to drag this up just so you have a little bit more room. And in the IPv4 header, there's something called the identification value, and that's going to give you like a sequential kind of number for every packet. So this one is, for example, decimal 6348, 6351, 6353, so on and so on and so on and so on. So now if we come over here to the outside of the firewall, view, packet details, same thing. I'm going to drag this guy up. IP, identification, so this one is 6358. So if I come back over here, that's 48, that's not it. 51, nope. 3, nope. 56, nope. 58, there it is. So now we're proving that the situation was the following. We have the client, nothing, 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 and then these last two got through. So that's telling us a lot, because if it was the first one and this one, then that would obviously give us a different pattern. So that means that all these other packets never got through the outside part of the firewall. So the question is, did it ever hit the inside interface of the firewall? And you can do a trace from there. But this is kind of important, because a lot of times when we troubleshoot these problems on the outside of a firewall or the outside of a router or whatever, I've seen this quite a bit, where the secondary trace here doesn't show any problems at all. Doesn't mean there was a problem as far as that interface goes. It just means from this part of the interface, the packets that are on this side don't have a problem. So we have to find out where these packets got dropped, and that's where we start to move our test points to the inside of the firewall, to the router, to the backbone, until we find out where these packets got dropped. All right. In this case, just a bit of a spoiler alert, because I'm not going to go through the whole case study with you. The inside of the firewall interface was dropping the packets. All right. It doesn't matter why. It doesn't matter, right? The point is, they weren't getting to the inside part of the firewall interface. Therefore, they're not going through the firewall. Therefore, So there you go, folks. Hope that helps you out. Have a good day. Bye for now.